So, hello everyone, good evening. Uh, let's start the week 12 content. Okay, so this week we are going to see problems based on Lissajous pattern and how that works. So, okay, so basically, Lissajous patterns are observed to find out the frequency of the signal as well as what kind of. Basically, we know the characteristics with respect to time, but we do not know the characteristics with respect to each other. So let's say that we have two channels in CRO. So if the variation of both channels with respect to each other is given, then it is a bit difficult to find out the frequency as well as the this phase difference relationship between both of them. Okay, so about that, what we can do. So basically, it is very useful if we get a plot of y versus x and how to identify which kind of waveforms are there. So we first thing is we do need to find out the amplitude as well as phase difference between both of the things. Yeah, good evening, Niranjan. So okay, I hope I am audible, right? Okay. Oh, is it not presentable? Okay, okay, कोई बात नहीं. ठीक, ठीक. Sorry. Yeah. Watch the recording after the lecture, huh? Okay, so we were discussing, if we have two channels and we have been given the amplitude as well as phase difference between them, then how to, draw the pattern, or other way around, if we are given with only Lissajous pattern, then how to identify amplitudes as well as phase difference between both of them. Okay, so this is the objective for which we study this topic, right? So let us start with various phase differences. So let us suppose channel one has one amplitude A sine omega t. Okay, and channel two has amplitude A sine same amplitude omega t and it has some phase difference, right? So that is omega t plus theta. So this kind of, we are given with the expression. Now we want to draw them because, on time axis, we know that both the signals will be like something. This will be channel 1 and channel 2 will be shifted by theta degree, isn't it? This will be theta. So on time axis, we know that this will be the behavior with amplitude A. Okay, but how do we plot them on x and y axis with respect to each other? How they will look with respect to each other? So that will vary, and that will be depending on the how much phase difference is there between both the signals. Okay, so let's see for first case if theta is equal to 0. Then what will happen? Both the signals will have the same amplitude as well as phase. So channel 1 will have, A sine omega t. Channel 2 will also have A sine omega t. Now, we got the relationship between both of them, like channel 1 is equal to channel 2, which means y is equal to x, if we are considering x, y. Now, the other thing is that on with respect to time as well, at t is equal to 0, x will be 0, y will be 0. Okay. At t is equal to pi by omega, what will happen to x? Will again be 0, y will again be 0. At t is equal to pi by 2 omega, x is equal to a, y will be equal to a. So this is following the relationship of a straight line. So if you draw the curve of y with respect to x, you will get a straight line. Okay. So as time is increasing, so this is going in this fashion. So the direction is also very important here, right? And it will go all the way till the maximum amplitude of the signal. So it will not exceed the limit A. Okay, so since the maximum value of y or x is A sine omega t and its maxima lie at pi by 2 or multiple of pi by 2, so it will be its maximum value will be A and minimum value will be minus A. Okay, after that, as sine will start reducing after pi by 2, so it will go in that fashion. So like that, it's a straight line will traverse through the straight line. Okay, so whenever this theta is equal to 0, okay, the characteristics of y with respect to x is a straight line. Okay, and if you have the information of phase difference between both the signals, okay, or you have the information of amplitude of each other, then you can easily find out the relationship between both of them. Okay, so in that fashion, what we can do is we can generalize this relationship at theta is equal to 0 degree, y is equal to x, and it's a straight line. Okay, so I hope it is fine. Now let us take the second case. when theta is higher than 0 degree and less than 90 degree. What will happen in this scenario? So x is sine omega t and Vy will be a sine omega t plus theta. And here theta is lying between 0 to 90, so we can take any specific angle. So let's take, 45 degree. Okay, so Vy will be a sine omega t plus pi by 4. Now, if we want to plot them on xy axis, at t axis we do know how the characteristics will be there. Okay, so here the Vx will be like that on time axis, and Vy will be shifted by pi by 4. Okay, on time axis we are fine with. Now on xy axis, we do not know what is the characteristics of both the signals. Okay, so on time axis we know that Vx is a sine omega t, and at theta equal to 45 degree, Vy will be shifted by 45 degree, right? But on with respect to each other, Vy, Vx, what will be the behavior? So at t is equal to 0, what will be the magnitude of Vx? Vx will be 0, right? Vx is a sine omega t, and at t is equal to 0, Vx will be 0. Okay, what will be Vy? Vy will be a sine pi by 4. If we plug in here, a sine pi by 4, so it will be a by root 2. So this, on this xy curve, if we plot at t is equal to 0, Vx is equal to 0, okay, and Vy is equal to a by root 2. And the maximum value of a is like that, okay. So this is a by root 2, okay. Now, at omega t is equal to, pi by 4, how this behavior will look like? Vx will be a by root 2, and Vy will be a, isn't it? So now, at this instant of time, Vx is a by root 2, and Vy is a. So like that. So we can also trace the curve, okay. Similarly, at omega t is equal to pi by 2. What will happen? Vx will become, a sine omega t. So Vx will be a and Vy will be a sine 3 pi by 2 plus pi by 4. So 3 pi by 4, right? So it will be again a by root 2. Okay. So Vy will be again a by root 2. Vx is a. So like this. Yeah. So like that. So we are tracing the curve and we will see where it is going, right? So till pi by 2 we have drawn. Now at pi, at omega t is equal to pi, so again Vx will be 0, okay, and Vy will be a sine pi plus pi by 4. So it will be, 5 pi by 4. So pi plus pi by 4 will be minus. So minus a by root 2. Okay. So in that fashion, you are going to have this Vx is 0, Vx is 0, and Vy is minus a by root 2. So it should come here. Okay. And similarly, at omega t is equal to, pi plus pi by 2, 3 pi by 2. If you plot, I hope you are able to get it, NS, right? Vx will be equal to minus a, okay, and Vy will be equal to a sine 3 pi by 2 plus pi by 4. So it will be a sine 7 pi by 4, which is 2 pi minus pi by, okay. So in this fashion, yeah. So like we are taking all the instances in this. Okay. So please interrupt me whenever you are not able to get anything. So we are what we are doing here that we do know the relationship between x and y in terms of time, but we are plotting against x and y. So we are taking all the instance of time and we are mapping with x and y. So what will be the magnitude of vx and what will be the magnitude of vy? So what kind of you know trajectory or locus we are getting, that we are plotting here, and it will be very helpful. I think while drawing it seems a bit tedious, but at the end of the day, you just need to keep in mind that what kind of locus is there for which cases. Okay, so that's what. So we are just starting with the first case. We will see more cases so that it will be very clear at the end. So here Vy will be how much? Uh, minus a by root. So Vy is minus a by root 2 and Vx will be Vy is minus a by root 2 and Vx is minus a. Vx is minus. So like that, this trajectory will, follow all the way to, and its direction is like we moved from this way to this way to this way to this way, right? So this is the locus of case when phase difference is between 0 to 90 degrees. Okay, first case was when theta is equal to 0, when there is zero phase difference between all of them. In that scenario, what was happening? That we were getting a straight line case. Okay. Now we are getting here kind of elliptical locus. So, so the special characteristics of this locus is it is lying between first and third quadrant. Okay. And it's clockwise direction. Okay. And let's suppose we are given with only this locus. Okay, and we want to find out the phase difference between x and y, both channels. Okay, so how to calculate that? So for that, you do not need to do anything special here. You just need to, theta is equal to sine inverse, you know, Vx by Vy. Okay. So at sorry, not Vx by Vy, V by V maximum. Okay. So take any instance here. For example, here at this instance, sorry, the magnitude is a by root 2, but maximum it can go till a. Okay. So we can write is equal to sine inverse a by root 2 divided by a. Because when theta, we took in this example, theta is equal to pi by 4. So when we take as angle of phase difference is equal to pi by 4, in that case, what was happening that all the time instances, at all the time instances, either it was coming 0, a by root 2 or a, none other than that. Okay. So if you take at any instances like at t is equal to 0 or at origin, that amplitude was a by root 2 and maximum it can go to a. And by plugging in this formula, you will get sine inverse 1 by root, which is nothing but 45 degrees, isn't it? And that's what we took here to just get started. When theta is equal to 45 degrees, this kind of locus was there. So this is how we try to find out other way around. This is what we was finding. Okay, we will take more cases, but this is what it is. And yeah, it is very important to, the expression for theta, how do we get, okay, so for theta expression, no problem. Yeah, so for theta expression, what we are doing, nothing, just, at any instance of time, you just need to note down the amplitude of that, locus. So here on this ellipse, if you take amplitude at this point as well, where I am pointing out, so we have this kind of ellipse. Okay, now its maximum value is a, that is fixed. Okay, that is not going to change. Now the transition point was how much? Either it was 0, okay, either it was 0 or a by root 2. Okay, here also a by root 2 and this a. Okay, so we have to consider, sorry, how much is the amplitude during the transition point. So for example, here it is a by root 2. Okay. And how much is the maximum value? So the slope is, this is in y-x plane, but in time instance, the curve is like sinusoidal, right? So from there we can easily interpret. But here this expression is given from this point, that what is happening at theta is equal to pi by 4, or sorry, omega t is equal to pi by 4. So at omega t is equal to pi by 4, the amplitude of Vx was a by root 2. Okay. And amplitude of Vy is a sine omega t plus pi by 4. So a sine pi by 2. Pi by 4. This is omega t is equal to pi by 4 plus pi by 4. It is shifted. So it is a. Okay. And theta is nothing but, you know, tan inverse Vx by Vy. Okay. So we have two signals like this. Okay. Orthogonally. Here also see Vx and Vy both are orthogonally. So the theta is nothing but tan inverse of Vx by Vy. So at this instance, at omega t is equal to pi by 4, Vx is coming a by root 2. Vy is coming a. So we are just plugging in the value of Vx and Vy, and we are getting the angle 45 degrees. We will see some more examples so that it will be very clear. Okay. If you are not able to get in this example, no problem. We will see some more. Okay. So this was when this direction was clockwise. Just keep in mind. Okay. We will revisit this. No need to worry. Okay. So now we will see the second case when theta is lying between 90 degree to 180 degree. Okay. Then again we have Vx is equal to Vm sine omega t, and Vy is equal to Vm sine omega t plus theta. Okay. Now we will see again a step by step. So for that we have to take some instance of time. So let's take omega t is equal to, again, you know, instead of pi by 4, let's take this time pi by 3. Okay, let's take this instance. Omega t is equal to pi by 3. Okay. Now, what will, oh, sorry, no, theta is higher than 90 degrees. So it should be higher than 90 degrees. So we can take 2 pi by 3. Okay. Now, yeah, 2 pi by 3 is fine. Okay. So, or for example, theta should be from 90 to 180, right? So theta will be 2 pi by 3 for our example. Okay. Now, omega t we can start with 0 degree. Okay. We will start with very simplified case. So at omega t is equal to 0 degree, what will be the amplitude of Vx? Vx will be Vm sine 0. So 0. Vy will be Vm sine omega t is 0 and theta is 2 pi by 3. So Vm sine 2 pi by 3. Okay. So how much will be the amplitude here? 2 pi minus pi by 6. So pi minus pi by 3 sine 60. So root 3 by 2 Vm. Isn't it? So this is the amplitude at omega t is equal to 0. So can we plot here now on xy plane? Yeah. So at t is equal to 0, Vx is 0 and Vy is root 3 by 2 Vm. But maximum value could go till Vm, isn't it? So let's first make the limit of Vm. So our locus should not exceed the maximum value. Okay. Minus Vm, minus Vm. Okay. Now at omega t is equal to 0, Vx is 0. So Vx is this one. Vy is this one. So Vx is 0. Okay. Vy is root 3 by 2 Vm. So root 3 by 2 Vm. So it will be closer to Vm. Okay. So this is root 3 by 2 Vm. So this is the first point we have achieved. Okay. Let's denote it with different color. Okay. So this is our first point. Okay. Slowly we will, trace all the points and we will make a trajectory. Now, can we take another instance at omega t is equal to, let's say the next angle, 30 degree. 30 degree is nothing but, pi by 6. Then in this scenario, what will happen with Vx? Vx will be equal to Vm sine pi by 6, which will be nothing but Vm by 2. Okay. And here Vy will be Vm sine 2 pi by 3 plus pi by 6. Great. So you are getting this. So it will be Vm sine 5 pi by 6. Okay. So if you calculate it, you will get how much Vm sine pi by 6? It will again be Vm by 2. So Vy will again be Vm by 2. Okay. So now Vx and Vy both are in Vm by 2, Vm by 2. Okay. So the Vm by 2, Vm by 2. So if you make this plot, it should come here, right? Yeah. So we have got 2 points. So can we further take on another point? Like if you take, omega t is equal to different angle, you will get further other points as well. So now we will take some extreme point as, omega t is equal to 90 degree. So at omega t is equal to 90 degree, what will happen with Vx? Vx will be, Vm sine omega t. So Vx will be Vm. Vy will be Vm sine omega t is pi by 2 plus theta is 2 pi by 3. Okay. So this is, 90 plus 120, 210. So sine 210 is Vm sine 210 is how much? Pi plus 30, right? So it will be half, isn't it? Minus, in minus, right? Minus sign. It's important here. So can we again draw on yx trajectory? So Vx is Vm and Vy is minus Vm by 2. So this is minus Vm by 2. And Vx is how much? Vm. So it will be at this point. So we have this trajectory, this locus is like this. Okay. Yes. Now, if you further draw it, let's say here we took omega t is equal to pi by 2. Now we will take omega t is equal to pi. Then what will happen? Vx will become 0. Okay. So let's take, take this case. Vx is equal to 0. Vy is equal to 120 plus 180, 300. So Vm sine 300. So it is Vm sine 2 pi minus 60 degree pi with minus root 3 by 2 Vm. Okay. So Vy is minus root 3 by 2 Vm. So here, and Vx is 0. So like this. Okay. So till this point, I hope it is clear. Vm by 2, 5 by 60 minus Vm by 2. So sine 300 is how much? Minus root 3 by 2. Yeah, sine 300 is minus root 3 by 2. Okay. So this is how we reached till this point. So I hope it is fine till now. It is fine till now. Okay. Now we can take omega t is equal to pi plus pi by 2, 3 pi by 2. Okay. Yeah. Yeah. Right. So at 3 pi by 2, Vx will be how much? Vx will be minus Vm. Okay. And Vy will be 3 pi by 2, it is to Vm sine 3 pi by 2 is 270 plus 120. Okay, so it is Vm sine 390 degrees. Okay, so basically 360 plus 30, so Vm sine 30, and it is Vm by 2. Okay, so now this time Vx is minus Vm. Yeah, exactly, Vm by 2. And Vy is Vm by 2. So we can plot Vx is minus Vm and Vy is how much? Vy is Vm by 2. So at this point. Okay, so since we are taking extreme steps, higher steps, so it will go like this. Okay, and finally it will, match like this. Okay, so this is the ellipse with such clockwise direction with maximum amplitude of Vm. Okay, and at any point of time, now, yeah, now you will ask that here we had, three different amplitude, Vm by 2, root 3 by 2 Vm and Vm. Then which one to take in calculation of angle? Here, what we did, initially we defined the angle, phase difference. That difference was how much? The theta was how much? The theta we took for initialization was, why is it hanging? So theta was 2 pi by 3. Initially we defined this angle and then we proceed to plot the ellipse. Yeah, great. So that is 2 pi by 3. Now, if we are given this ellipse separately, now we are given with this ellipse, then how to calculate the angle? Okay. So again, we can write that expression. Theta is equal to tan inverse Vx by Vy. Okay. Now, to calculate this Vx and Vy, take any instance, for example. Okay. Take any instance. Okay. Not tan inverse, it should be sine inverse because we have the sine as a signal, right? So sine inverse. Our both signals are defined in terms of sine, so that is why we are taking in terms of sine. Okay. And since this ellipse is lying in second and fourth quadrant, so we will have to do as, this in terms of minus plus 180. So our angle will be 180 degree minus sine inverse Vx by Vy. At origin, you can see when this is crossing, so at this distance, what is the amplitude? Okay. Just a second. Vx by Vx max. Vx by Vx max. Okay, when you are going to use tan, then Vy by Vx. Okay, theta is equal to tan inverse Vx by Vy. Otherwise, if you are calculating with maximum with respect to maximum, then you are going to consider this sine expression. So please stick to this one. Okay. The second one is just to interpret that with respect to tan. So how much is the slope? Okay. So at this instance, the amplitude is root 3 by 2 Vm. Okay. And the maximum value is anyway Vm. Okay. So when it is crossing any of the axis, okay, at intermediate transition, it had, Vm by 2. But at axis, at, origin lines, either y vertical origin lines or horizontal lines. At axis, it is cutting at root 3 by 2. Here as well, here, here. Minus root 3 by 2 Vm. Minus root 3 by 2 Vm. All the origin points are getting cut at or intersected at root 3 by 2 Vm. Okay, so got it why I am taking this point root 3 by 2 Vm. So here at Vx, we can plug in the value of root 3 by 2 Vm and this maximum, Vx max. Vx max is nothing but V. So you will get 180 degree minus sine inverse root 3 by 2. Okay. And root 3 by 2 is nothing but 60 degrees. So 180 minus 60. It is 120 degree. Okay. And why I have to consider 180 degree minus? Because it is lying in second and fourth quadrant. Okay. The ellipse upper part and lower part is, flipped from the first case. So that we have to take 180 degree minus. Okay, if any doubt is there, we can clear it out now. Or we can see some more cases. Okay. So this was for, so we have derived 3 cases. Let me just, summarize it. When theta is equal to 0, our curve is like this, a straight line. Okay. It is going till Vm minus Vm. Then it will again come back like that. And it will again go to Vm. So this was the pattern. Okay. This was the pattern here. Now for second case, when theta is varying from 0 to 90 degrees, then what is happening? We have ellipse in first and third quadrant. Just a second. Okay, so this is how our characteristics looks like for theta when varying from 0 to 90 degree, and it will be clockwise. Now in case 3, when theta is varying from 90 to 180 degree, in that scenario, our ellipse was in second and fourth quadrant, okay, like this. Okay, so this one was Vy, this one was Vx, so this one was Vm, this one minus Vm, Vm minus V. Okay, and it was also traversing in clockwise direction. So direction is very important. When the angle range will change, then direction identification will be the major thing. Okay, so till now we have seen 3 cases, right? So first case, when theta is equal to 0, it is a straight line. When theta lies between 0 to 90 degree, it is a ellipse which is lying in first and third quadrant. And when theta is lying between 90 to 180 degree, then it is lying in second and fourth quadrant with the clockwise direction. Okay. Now, when theta is equal to exactly 90 degree, what will happen? Case 4. When theta is equal to 90 degree, then what will happen? Again, Vx is nothing but Vm sine omega t. Vy is Vm sine omega t plus theta, that is pi by 2. Okay. Again, we have to perform the same procedure. Okay. When omega t is equal to 0, Vx is nothing but 0, Vy is Vm. Okay. Then we will have two trajectories. Okay. So we will solve, some around 10 problems to get acquainted with this topic, and we will solve all the problems. Okay. So here at omega t is equal to 0, Vx is 0, and Vy is maximum. That is okay. At omega t is equal to pi by 2. What will be Vx? Vx will be Vm, and Vy will be pi by 2 plus pi by 2 pi. So it will be 0. So Vy will be 0. And Vx is maximum V. So V. Okay. At omega t is equal to pi, Vx will be Vm sine omega t, which will be equal to 0. And Vy will be equal to pi plus pi by 2. So pi plus pi by 2, 3 pi by 2. So it will be minus V. So here, in this scenario, it will lie. So minus. So it is following a circle trajectory. And with time, it is rotating in clockwise direction. Okay. So at different, just let me change the earphones. Just give me a second. So with time, it will complete its circle like this. Okay. So at a specific 90-degree angle, okay, at a specific 90-degree angle, it will be circle and in clockwise direction. So case 4, when theta is equal to pi by 2, it will be circle of, how much is the radius? Radius is nothing but the amplitude of the signal. Here in this case, Vm. Okay. And direction is clockwise. Okay. So this is how the Lissajous pattern of, when phase difference between two signals which we are feeding to a CRO with two channels. If the pattern is circular, then you can identify the phase difference between both the signals is 90 degree. Okay. If ellipse is there, then you can also find out that if it is lying in first or third quadrant, then the phase difference between both the signals lie between 0 to 90 degree. How much is there, you can identify with the magnitude difference, right, from the slope. So this was the, all our four cases till now. So we have covered till 180 degree, right? Now what will happen after 180 degree? So it will reverse. After 180 degree, this case will reverse. How they will reverse? When theta lies between 180 degree to 270 degree, what will happen? So we can see, and after that we can generalize. Again, here we can take, theta as, 180 and 270. So in between, so 210 we can take. Now here, if we take theta is equal to 210 at omega t is equal to 0, Vx is 0, and Vy is Vm sine 210. So it will be minus Vm by 2. So it is starting from minus Vm by 2, isn't it? So let's see on the xy plane. Vy at 0 itself, it is getting started from Vx is 0 and Vy is minus Vm by 2. So this is the first point, okay? At omega t is equal to pi by 2, Vx will be equal to Vm, Vy will be equal to 210 plus 90, Vm sine 300. So 300 will be how much? 2 pi minus 60, so root 3 by 2. So minus root 3 by 2 Vm. So Vx is Vm, Vy is minus root 3 by 2 Vm. Okay, so Vx is Vm and Vy is minus root 3 by so at this point. Okay, so this is the second point. Okay, so this is how it will go. Now, in other case, when omega t is equal to pi, Vx will be 0 and Vy will be Pm sine theta 210 plus 180, so pi 2 pi 30. So Vm sine 30. Yeah. It will be 390, so I am writing in terms of equivalent. So it will be Vm by 2. So Vx is 0 and Vy is, so if we plot all the points, it is traversing in anti-clockwise direction. So now after 180 degree, our direction of rotation will be reversed. Now, if you see anywhere the direction is anti-clockwise, you immediately know that theta is higher than 180 degree. Okay. Now, the locus or trajectory is similar to which case? When theta was lying from 90 to 180, right? So in our third case, right? And theta is lying between 90 to 180 degree. 90 to 180, 180 to 270. Okay, both the trajectories are same. Only the difference is direction. Okay, so that's what I wanted to conclude here. That when 90 to 180 degree is the phase difference, the ellipse will be there, which lie in the second and fourth quadrant. Okay, and but the direction of rotation is clockwise. When when this angle varies from 180 to 270 degree, the direction of rotation is anti-clockwise. That's what all you need to remember. Okay. Similarly, I can. Okay, you got it right. Yeah. So similarly, I can write. You can also draw at your own. Okay, in laser time. So when theta is 270 degree to 360 degree, it will again be ellipse. But this time it will again be in first and fourth quadrant. Okay. And the direction of rotation will be in this scenario. What will be? The direction of rotation in this scenario, what will be? When theta is lying from 270 to 360, anti-clockwise. Excellent. So it will be anti-clockwise. So now I hope you have got the idea, isn't it? Yeah. So we have covered all from 0 to 360 degree, apart from a specific angle. So when theta was 90, it was circle. When theta was 90, it was circle, isn't it? When theta will be 270 degree, again it will be circle. Okay, you can also draw that. I think so. I was getting. Okay, no problem. So, okay, so when theta is 270 degree, again it will be circle. Only what will change? Direction will change. Okay, so now the circle will be there. Okay, the direction will be anti-clockwise. Okay. Okay, cool. Now we are left with only one case when theta is equal to 180 degree. What kind of locus will be there? A straight line. Excellent, 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 excellent. And so it will be a straight line. Okay. Only the fashion will change. No, no, no. What will change? It will be now y will not be equal to x. It will be y is equal to minus x. Okay, so like this. In second to fourth quadrant. Earlier it was in first and now second and fourth quadrant. Okay, y is equal to minus x. Okay, so we have covered all the part of this Lissajous pattern. Okay, so we got the idea, how to calculate amplitude and phase difference between both the signals. Only thing now which is left with us is, finding the unknown frequency. If we are given with the one frequency, or we have two signals, horizontal and vertical. If we are given with horizontal frequency, we need to calculate the vertical frequency. Okay. So now calculation of frequency. So let's suppose we are given with such kind of Lissajous pattern, like, let me draw some random signal. Okay. Now, the frequency, this is y, this is x. Okay. Now, the relationship is like that. Fy by fx is equal to opposite, like number of horizontal tangencies divided by number of vertical tangencies. Okay. And those tangencies should be drawn such that maximum intersections should occur. Okay. So when we draw the tangency for this given signal, okay, how do we draw? So let's say vertically it is in the same way. So it is cutting, how many points? 1, 2, 3, 4. One intersection, 2, 3, 4. Okay. So vertical tangency is 4. Okay. Horizontal tangency should be maximum. So it can only be 2. 1, 2. Are you getting the idea? So now for such kind of Lissajous pattern, you can write Fy by Fx is nothing but 1 by 2. Okay. Then in any problem, if you are given such pattern or number of tangencies, then you can calculate the frequency with respect to each other. Okay. One frequency you might be knowing, and other frequency you can calculate. So let's proceed with some problem now. Okay. We have learned so many theories. So now it's time to apply those theories. Okay. So a problem is a gate problem. Okay. A stationary closed Lissajous pattern on an oscilloscope has 3 horizontal tangencies. Okay. And 2 vertical tangencies. Okay. And input frequency was, horizontal input frequency is nothing but 3 kilohertz. And we were asked to find out the vertical frequency, vertical input frequency. It was asked in GATE 2017. Okay. We needed to calculate it. Can we calculate it now? So let us consider as Fy Fx. Fy by Fx. Oh, 2 kilohertz. 2 kilohertz. Let's see. Okay. So the number of horizontal is 3. Right. So you actually interchange the numerator with denominator, ns. So uh, Fy will be, aligned with on the right hand side in horizontal tangency. So 3 and vertical tangency will be 2. And this Fx will be 3 kilohertz. So now Fy will be 3 by 2 into 3. So it will be 4.5 kilohertz. Okay. Okay. No problem. Just do not commit the mistake in exam. Okay. That's all. Okay. Now, one very interesting problem. It was asked in 2014. Okay. So let's see. We are given with two different signals. One signal is triangular. Okay. Like this. This is a V with amplitude is given 1 and -1. Okay. And this is with respect to time. Okay. Not with respect to each other. Okay. And other signal is given as a square wave. Like this. So, and time period is such that this is your time period. T, T by 2. Here also it is T by 2, T. Okay, this is again V and its amplitude is 1, -1. Okay, so these both signals are given. Okay, ignore the upper part. Now, which kind of waveform will be displayed on the screen with respect to Y and X? Okay, so let's suppose that this is, Vx and this is Vy. So which kind of waveform you will observe on Yx? So Vy, Vx. So we derived all the waveforms on the screen of CRO with respect to sinusoidal signal, but now we do not have any sinusoidal. We have triangular as well as a square wave. Which kind of waveform we will see? So we will see, okay? So again, we will stick to our strategy. Okay, what is happening at t is equal to 0, t is equal to t by 2. Okay, so we will follow our basic strategy. No need to get nervous by seeing multiple different kind of signals which we haven't studied in our theory. Okay, just a second. No power mode. Yeah. Yeah. So now we have both signals. Okay, at t is equal to 0, Vx is 0, Vy is 1. Okay, that much is fine. Now we'll proceed to t by 2. At t is equal to t by 2. Vx is again 0 and Vy is 1. Vy is again 0, right? So at t is equal to 0, Vx is 0, Vy is equal to 1. This one. At t is equal to t by 2, Vx is 0, Vy is 0. Okay, like this. Now, further, if we see at t is equal to t by 4. Okay, middle one we will also see. So at t by 4, both is 1, isn't it? Both are 1. So Vx is 1, Vy is. So this will be like here. Okay, so initially it is at, this is first point, this is second point, this is third point. Okay, now fourth point, at t is equal to t. T is equal to t again, Vx is 0 and Vy is how much? It is being transitioned. Okay, it is getting transitioned from -1 to 1. Okay, okay. At t by 2 also, at t by 2, Vy is, sorry. This second point we have to again consider because it is getting transitioned. So at t by 2, at this instance, it is coming from 1 to -1. Okay, because since it is a step waveform, so it will vary and that should be reflected on xy waveform. Okay, and at t also it is getting from -1 to 1. Okay, Vy is 1 to -1. That t is equal to t, Vx is equal to 0 and Vy is equal to -1 to 1. Transitioning from -1 to 1. Okay, so now first point at t is equal to 0, Vy is equal to 1. At t is equal to t by 2, Vy is varying from 1 to -1. And Vx is 0. So Vx should be 0. Okay, and Vy should vary. Vx should, let me, just to show the transition, let me erase all other points. Okay, so this was the first point when Vx is equal to 0, Vy is equal to 1. Now we are seeing the transition at t by 2. So Vx is 0, okay, Vx is 0, and Vy is varying from 1 to -1. Okay, 1 to -1. So like this. Okay, now after t by 2, after t by 2, at this instant at t, it is going again. Just give me a minute. So we'll have to go step by step. T is equal to 0, t is equal to t by 4, t is equal to t by 2, t is equal to 3t by 4, t is equal to t. Okay, these 5 instances we will focus on. At t is equal to 0, Vx is 0, Vy is 1. At t is equal to t by 4, again Vx is 1 and Vy is 1. At t is equal to t by 2, Vx is 0 and Vy is varying from 1 to minus 1 to minus 1. Okay, or let me write it 1 to minus 1. At 3t by 4, Vx is minus 1 and Vy is 3t by 4, also minus 1. Okay, and at t is equal to t, Vx is 0 and Vy is going from minus 1 to 1. Okay, so we have these 5 instances. Now we want to plot on yx. Okay, so the first point is Vx is 0, Vy is 1. So this one. Okay, now the second point is Vx is 1, Vy is also 1. So Vx is 1, Vy is also 1. So this point. Okay, now the second, after this, Vx is 0 and Vy is traversing from 1 to minus 1. So on this axis. Okay, till now it is fine. Yeah, because it had to traverse through Vx is equal to 0. That's why I have to come back at Vx is equal to 0 locus. Now the next point at 3t by 4, Vx is minus 1, Vy is minus 1. So how to indicate this point? Right, Vx is minus 1, Vy is minus 1. After that, Vx is 0. Again, it will come to this point and it will again go all the way to 1. Okay, so this is how our curve will look like. Now I hope it should be fine. Still, if any confusion, I can again explain it once, because it is very important problem and such type of problems are sorry, frequent in competitive exam like GATE. So it is a GATE problem and it is a very good problem to how to plot by considering all the points, all the transition points. If you miss the transition point of t by 4 in this problem, you are gonna miss this solution, right? So that's what I did. I skipped t by 4 and I directly jumped to t by 2 and I do a solution. Okay, so shall I explain it once more? Okay, so I just wrote all the instances where the transition is happening. T is equal to 0, t by 4, t by 2, 3t by 4, t. Okay, and at t is equal to 0, Vx was 0, Vy is equal to 1. So this first point came in picture. This was the first point. After that, Vx become 1 and Vy also become 1. So this second point. So from here we transit to after there. Okay, so after there we again came back Vx equal to 0 and Vy traversed from 1 to minus 1. So this was the trajectory. Okay. Sorry. Now at 3t by 4, again Vx become minus 1 and Vy become minus 1. So this was the trajectory. And finally, Vx becomes 0 and Vy from minus 1 to 4. So now this way, again it retransit. Okay. So here so this was the locus. And we had been given with 4 options and we had to select one option. Okay. So this was kind of solution. And also this kind of trajectory was given with inverted. So X was like that. One option was kind of this. So Vy. So we had to select appropriate option. Okay. The first one, exactly. The first one would be correct. Now, let's see the next problem, which is also very good problem. Okay. So now we are back to sinusoidal signals. So two sinusoidal signals. Okay. First signal is given P1 is A sine omega 1 t. The second signal Q P2, let's call it P2. P2 is not given. So let's assume amplitude A2 sine omega 2 t. Okay. We have to, if we are not given with the information of magnitude as well as angle or frequency, magnitude and frequency, so we have to consider different frequency than the fundamental. So we are given with two signals, but first is known, second we do not know. But we are given with Lissajous pattern. What kind of Lissajous pattern? So it is two circles. This kind of Lissajous pattern is given. This is x-axis. This is y-axis. Okay, so what do we need to find out? So we need to find out the second signal amplitude A2 and omega 2 with respect to amplitude of the first signal in terms of A and omega. Like let's suppose A2 is equal to K times A and omega 2 is equal to X times omega 1. So we need to find out K and X. Okay. So can we find out? So from Lissajous pattern, frequency, how to find out the frequency by calculating the number of tangencies. So first thing we can do, we can find out the number of tangencies. Okay. So how many number of tangencies will be? So let's Fy by Fx, or let's suppose we are given. Okay. Yeah. Yeah. Fy by Fx is, yeah. So this P1 is fed to X of CRO. P2 is fed to Y. We will have two channels in CRO, so that is how it is done. Okay. So X is omega 1. So Fx is omega 1, right? So omega 1, omega 2 is equal to horizontal tangencies divided by vertical tangencies. So how many horizontal tangencies? Sorry. So horizontal tangency, if you draw, the maximum tangency should be made, right? So 2. Okay. The maximum tangencies will be 2. So it will be 2. Vertical is itself given, right? 1, 2, 3, 4. So omega 2 by omega 1 is half. So omega 2 is nothing but omega 1 by half. So we are done with the frequency. So omega 2 is nothing but half of the omega 1. Okay. What about amplitude? So amplitude will be same because it is a circle. So in circle, if you remember the trajectory, the both amplitude was the same. And generally in this largest pattern, what do we find? The maximum and minimum. So y maximum is also a, and x maximum is also a, isn't it? Because the radius is itself a. Half, no. So that's what I am explaining, because this is a circle. Okay, so on x hand side, what is the maximum amplitude? Whichever is on the y hand side. So amplitude will be equal on both sides, isn't it? Remember how did we draw the radius? How did we draw the circle? Just see this pattern. On x side also it is the maximum a. Okay, I got it. How you are getting confused with half. So you are seeing it as two circles and it is shifted. So it is just shifted. Okay. So if you see the circle case, that is why that basic of circle case we have to keep in mind. In circle case, whatever the magnitude was on the y-axis, if you just shift it, the signal, because this is a CRO signal, so it can be easily shifted. So, but what is the aspect ratio from x to y? It is just two circles. So y and x will be, accordingly, it will be a and a. Yeah, exactly. That's not a problem. That's exact thought. I got it. Why did you say 2a? Because you are seeing it here. From if you measure it from here, it will look like a 2a, and it is minus 2. Okay. But in the surface pattern, we have to only focus on that pattern. So it is just a circle. So for circle will be made with respect to when the magnitude of the y and x is equal. Okay, and it will be more clear when we conclude towards the solution. So now, if you can write, so, sorry. So if you write P2 is equal to a sine omega 2 is nothing but omega 1 by 2 into t. Okay, but is this correct? Is this correct? Because we have been given with circles, so we will also have some phase angle. Yes, so that phase angle of the circle. So sorry, I don't think I have provided the direction of the notice. So direction is like that, clockwise, and on bottom hand it is anti-clockwise. So bottom one is nothing but the mirror image along the x-axis. Okay, so if you see on the positive axis, it is a clockwise and it is a circle. So again, you have to consider it in terms of circles. So how much will be phase difference there? Since it is a clockwise. Sorry. So I can write it a sine omega 1 t by 2, okay, plus 90 degree. Okay. Will that be correct? And no need to get confused with the second circle. Okay. Okay. So we were getting, verified by multiple concepts. So we needed to find out the phase as well as we needed to find out the frequency. Okay. So that is how we solve the problems based on Lissajous pattern. Any final doubt in this problem? Shall we move ahead? Okay, so we will solve one more problem of such kind. Okay, then we will be clear. So in this problem, it is said that XT and YT, XT is horizontal plate. Okay. Now XT is given in terms of P sine 40 plus 30 degree. And we needed to find out the other signal YT. Okay. We need to find out the YT. Okay. Now another additional, uh, okay, amplitude part. Okay. Yeah. See, if we are given with, such kind of circle, Y, X. Okay. So, okay. Then we have to consider the center here. Even the center, even this is the origin, this will be the center. Okay. Thank you, NS. Uh, so this is the center here, right? And its radius will be, how much is the amplitude. So AA, in our problem, it was given A sine omega 1t. So it is A. Okay. So no matter wherever the circle will be placed, okay, the amplitude or this trajectory will be same with amplitude y is equal to A anything, A sine omega t if you are writing. If you repeat it along the y-axis, okay, let me repeat it once more. Okay, let's suppose this is the pattern we are given with. Then what will happen? Then this amplitude will not change. This will change only the frequency, because now if you draw a trajectory or if you cut it, in this fashion, you will get 1, 2, 3, 4, 5, 6 trajectory on the vertical side. So it will only change the frequency, but the radius of our circle is fixed as A. Okay. I hope you are getting. So all the circle have the radius A. Okay. If you keep increasing the number of circle, what you are doing, you are reducing the frequency. Okay. Just that you are changing the frequency. Okay. Great. So let's see this problem and you will be, much more clarified about it. We are given with, uh, we are given with that we have 8 signal. Okay, this is kind of signal. It is written that it is producing a vertical figure of its display. Okay, this kind of figure is not drawn. Just I am drawing for your reference. Okay, so the XT horizontal plate equation is given. Now we need to collect the vertical plate equation. Okay, so how much will be that? So please let me know the equation of YT here. So the frequency for sure it is going to be divided by half. Okay. Now the amplitude and phase is the thing that we need to care about, right? So if we are given with circle, okay, then again the same story will repeat, right? The angle will be shifted by 90 degree, but in what direction? So mm, the direction is assume it in this direction. So the same story it is. This I think this problem was repeated. Okay, so it will be its amplitude will be same again. Okay, P sine frequency will be divided by half plus 90, so 120 degree. Okay, now let us move towards the other problem. Yeah, so here we need to match between different scenario. This is y, this is x. Okay, A, B is like that. C is an ellipse like this. D is another ellipse in anti-clockwise direction. is like that. Ellipse in first and third quadrant. Like that. Okay. Now we have to identify the phase difference among all. So one is phi is equal to 0. The second is phi is equal to pi by 2. The third is, when phi is equal to pi by 2 to 3 pi by 2. Fourth is phi is equal to 3 pi by 2. So we have to match among them. Okay. So can we do that? Yeah. So as we have discussed in at the starting of this lecture, okay, so we can easily match now, right? So the case corresponding to phi is equal to 0 will be a straight line in first and third. So first will be matched to A. The second phi is equal to pi by 2. Okay, so it should be circle, but no circles are given. So we cannot match here. Okay, the third case is pi by 2 to 3 pi by 2. 92, is it 92 that? 90 to 270 pi by 2 to 3 pi by 2. Okay, 90 to 370. So it will be an ellipse. Okay, it will be an ellipse, but it will be, you know, second to fourth quadrant, right? 0 to 90. 0 to 90, it was ellipse, but first and third. 90 to 180 and 180 to 270, it was again an ellipse, but it lies in second and fourth quadrant. Okay, but directions should not have been mentioned because for 90 to 180 it will be clockwise and 180 to 270 it will be anti-clockwise. Okay, then it will be matched to F. And when phi is equal to 3 pi by 2 means 270 degree, again it should be circle in anti-clockwise direction. Which kind of question? Okay, assume it as circle. If no circle are given, then we are done. So this is how, all the cases were considered in this lecture. Okay, so I hope you got the better idea of Lissajous pattern, right? And you will be able to solve all the problems based on Lissajous pattern. So thank you for joining. Bye bye. Good night.